Coming to here, cause of buoyant force. So as we know in yesterday's class, we studied that if any body is immersed in a container, either partially or completely, then the liquid will always exert the force from the bottom of the container in upward direction. That is why that force is called as the force which is trying to push the object, understanding, in upwards. That is what we used to call as, what is that force we used to say? Upthrust, or we used to call as, everyone should tell, buoyant force. Is it yes or no? And the phenomena of applying the force from bottom of the liquid, we used to call as, what is the phenomena? Who is to known as? Nobody? What is the phenomena? Buoyancy. So, as I told you, maybe a body is fully immersed in the liquid or partially immersed. Always the liquid is trying to exert the force in the upward direction, trying to push that object away from it. So that is what we used to call as buoyant force. Now, what is this cause of buoyant force? Let us discuss in our today's class. So now, as we know, we all studied the properties of liquid pressure or fluid pressure. So if you take the fluid inside the container, the fluids will exert pressure in all the directions. Is it yes or no? That is what we studied in the first point. Everybody? If the fluid is present inside the container, the fluid will exert the pressure in all the directions of the container. Is it yes, guys?
Yes, sir.
Yes, sir.
If I select the fluid at different levels, suppose this is the height 1 and this is the height 2. Now, if I measure the pressure here, P1 and P2. So which surface the pressure is greater? Anybody can tell?
P2, sir.
P2, sir. Also. So P2 pressure is greater than P1. Because why, guys? What is the reason behind? Because
depth increases. Sir.
Understanding. So that is what we know. If the depth increases, then pressure also. If the depth increases, pressure also what will happen?
Increase, sir.
No, that is what you have to remember. And next point, if I select only at particular point, for example, I selected only at particular level. So this is what my level. Now, at this point, all the directions, pressure is what? All the directions, pressure is equal. Do you understand, everybody? Same or uniformly distributed in all the directions. Even that law is only called as, we are having some law name called as. What is that law called as? All of you? Pascal's law. And also we know that the last point of liquid pressure or fluid pressure, density of the fluid. So density of fluid is increases, then what will happen? The force exerted by it is also increases. That is what pressure we can say. So density of pressure is greater, density of given fluid is greater, then pressure exerted by it is also higher. If density is less pressure. Density is more pressure. Yes, Mr. Haris Eras, Omar, till here any doubt? Aswin?
No doubt, sir.
No, sir.
Now, with the same thing, as I taught you the definition of buoyancy yesterday. So, buoyant force means the tendency of a liquid which will exert an upward force on a body which is partially or completely immersed in it. Is it yes or no? All of you, have you all written the definition? If any object is partially or completely immersed in a liquid or fluid, then a liquid will exert an upward force immediately on that immersed object. Immersed means falling into the liquid. So that force only, the tendency of exerting upward force when the object is immersed fully or partially is only called as buoyancy. And the force is called as upthrust or buoyant force. Now, let us discuss very in detail what is the cause of buoyant force. Now, I have taken one beaker. Now, I dropped one object. Now, this object is having two faces. Anybody can tell me what is the two faces? One is upper face, and another one is what? Anyone? Another one is what?
Lower.
Lower face. Now, observe, this is what I used to call as object. What is this called as, everybody? Object. Okay. And the blue color one, which you are seeing, is called as, what is that called as? Yes, liquid. Now, observe very carefully. Here, I want to explain you very well. Now, you tell me, if any object is inside the liquid, now tell, is upper face is very deep inside or lower face is very deep inside? Yes, sorry. Of course, it's the same object. Now, my question is, where the pressure is greater? Which is very deep inside, upper face or lower face?
Lower face.
Lower face. So lower face is very deep inside. So that, let me take upward force. Down, from the down, it is acting upward. So that, what is the name of that force called as? Everybody. It is called as upward force. Let me take it is F2. Now it is acting from top. What is it called as? Anybody? What is it called as? Downward. You should tell me downward force. Let me take F1. Now, if we take this left side and right side, at any point, if you take at any point, this level or this level or this level or this level or this level, this level, at a particular depth, the pressure in all the directions, what will happen? Anybody? Pressure in all the directions, what will happen? Hari, pressure in all the directions, what it is?
Equal, sir.
Equal. But have you noticed it? It is in what? Opposite direction. Understand, everybody? So this side liquid is exerting pressure here on this object. This side liquid is exerting pressure on this object. But both are at the same depth or different depth? Same depth or different depth? Same depth. So this side pressure exerted by fluid and this side pressure exerted by fluid is cancelled. Is negligible. Is it yes or no? Yes or no? All of you? So negligible. Now, if you'll notice it, only where the pressure is varying, where? At the bottom surface and the upper surface. That is what upper face and lower face only. Because upper face and lower face are at different depth. But if we take the sides, at any depth, the pressure in both the directions is same. So that both will be negligible. But where only the pressure is varies, everybody? Where the pressure is varies? At the lower face and the upper face, means here and here. So that is only causing for buoyancy force. Do you understand, everybody? So the lower face is more than the pressure at the upper face. Is it true or not? Anybody? Yes?
Yes.
Yes. So right side and left side, pressure is equal and opposite. So they will cancel the effect of each other. But if you notice the force exerted on the upper face, force exerted on the lower face, you can see the force exerted by the body in downward direction is less than the force exerted on the lower face in the upward direction. Because a pressure at lower face is more or less. I want the answer from you. A pressure at lower face is more or less. Everybody?
More.
More, sir.
Why? What is the reason? Anybody? Harizairaj, Umar, Mitakshri,
That
Rani?
depth increases, sir.
Yes. So the depth is increases. So the pressure at lower face is greater compared to the pressure at upper face. So that is why the net force, like our salary, net salary, we can say, the net force is equals to net force. What is the difference between them? Who is greater? Upper face or lower face? More pressure. Upper
Lower face.
face. Everybody. Upper face.
Lower
Face.
Lower face.
Lower face. So lower face, what force is acting? Upward force or downward force? Lower face.
Upward force.
Upward force. So who is greater? Upward force is greater or downward force is greater? Anyone?
Upward force. Sir.
Upward force is greater. Because why? It is at lower depth. Understand? Sorry, more deeper inside or higher depth. So depth is increases, pressure is increases. So pressure is increases. We know the formula. Pressure is directly proportional to force. So pressure increases, force also what? Increases. So the net force is equals to F2 minus F1 means what force it is? Upward force minus what, guys? Minus
Downward force.
downward force. So that is the reason behind, all of you observe, behind buoyancy concept. Because the upper face of the object and lower face of the object at different heights. So the force exerted by the liquid from the bottom as it is in the deeper depth, so that the force, the pressure is also greater compared to the upper object. So that is why you can see if any object will settle at the bottom. For example, I have thrown one stone into the water. Now you tell me in which surface of the stone a pressure is more, either at the bottom or at the top. Of course, it is deeper inside the water, completely sink. Now, where the pressure is more, either here or here. Anybody? Let me take this
Bottom,
one.
sir.
At least the bottom only. Because even though entire stone is sink, but still the bottom surface is more deeper than upper surface. So at this point, the pressure is greater. Do you understand, everybody? Yes, please. All of you.
Yes,
That is what you have to remember. So that is only causing for buoyancy force. So I hope everybody understand what is the reason for buoyancy force. So here one point you should remember: the pressure increases with depth inside the liquid, but remains same at the point on horizontal level. Yes or no? We all studied or not? At a given horizontal level, the pressure is same at every point, but vertically upward and downward, the pressure is varies based upon the depth. Is it okay, Akilan? Arun Kailash? Understand? That is what is the cause of buoyancy. How many of you understand? Abhinav, you understand what is the cause of buoyancy?
Yes, sir.
Yes, so please make it. So this diagram will explain you what is the cause of buoyancy. So the net force is equals to what, guys? Always the net force is equals to upward force minus downward force. So the net force on the body, now you tell me, is it in upward direction or downward direction? Anybody? For example, I want to teach you normally. Now, for example, two boys are fighting. Now, this boy is more stronger than this boy. Okay, let me take this boy is B and this boy is A. Now, if both are fighting, so now you tell me, if this boy is more stronger than this, then displacement is towards to this side or towards to this side? I want to know. Anybody?
Towards right, sir.
Towards to right side, not left side. Why?
Because he is stronger, sir.
Is stronger. Same way, as we know, at the lower phase, the pressure is greater compared to the upper phase. So now the lower phase is experienced by upward force and upper phase is experienced by downward force. Now you tell me, now the net force is subtraction of upward force minus downward force. Now the net force will act what direction? Upward force or downward direction? Upward or downward? That is what my question. Everybody, all of you? Is the net force will act upward direction or downward direction? I want the answer from you all. Yes, please.
Upward direction.
Upward direction. That is the reason. Note it. Any object is immersed in the water or any liquid. The weight of the liquid is shows less than the weight of the object in earth or atmosphere, air. Do you understand, everybody? So please remember, right? The net force on the body is in upward direction. This net force on the body in upward direction, because who is greater, upward force or downward force?
Upward.
Upward force direction is the buoyant force, which reduces the weight of the body. Which reduces the weight of the body. So of course I don't have practical thing, but I have shown practical is movement. Okay. So till here, any doubt? Anybody? Everybody, have you understand? Really? Please. Clear? Now, right. Thus, we can say that thus we can say that the difference, difference the difference in pressure on the which surfaces, guys? On what surfaces? On what surfaces? Upper face and lower face. Understand, Mr. Omar? Upper and lower faces of the body, pressure on the upper and
Sir, can you hear me?
lower faces of a body. Which one? Is it outside body or immersed body? Anybody? Where it will exert? Immersed body or our body which is outside from the liquid? Anyone?
Immersed body, sir.
Immersed. It must be immersed. It may be partially immersed or fully immersed. It doesn't matter. Immersed in a fluid gives rise to the upthrust. What is another name of upthrust, Mr. Haris? Mr. Johan, what is another name of upthrust? Don't know that also. Upthrust exerted by the fluid on the body. In which direction, guys? Upward direction or downward direction? Upthrust. What direction, Abrami? In upward direction.
Upward direction.
That is what it is. Mitakshri, are you clear? Mitakshri, what is the cause of buoyancy force now?
Yes, sir.
Okay. Harish, Zeras, Akilan, anybody is having any doubt, please kindly ask. So this diagram is very important, and this one, so please write it till here. Anybody is having any doubt, please let me know. Now, if you don't have doubt, now I will show you. Remember, any kind of object, if it is immersed in water. So as we know, mass and weight, who is always remains constant and who will varies from place to place? Anyone?
Mass remains constant and
Mass
weight
remains
varies.
constant and weight is not constant, as we all people knows. Now, let us discuss one more important concept which will always boost up our knowledge. So that is what we can see. If any kind of object, if it is immersed in any kind of liquid, the weight on normal air, the weight after immersing is
Sir,
varies. Okay. Now I will show you in one experiment, so which will make you very clear to show that how the weight of the object is decreases when it is immersed in the water. Do you understand, everybody? So what is the reason behind the weight decreases? I told you. What is the reason behind? Because of what force? Upthrust. Buoyancy force. Because of upthrust, the liquid will experience less weight. Now, so observe very carefully. It is there in our book also. So this is the picture. If you will observe clearly, you can understand everything. Now, as we know, two physical quantities we studied. One is mass and another one is what, guys? Another one is weight. Now, if you will take the mass is always what? All of you. Mass is always constant. But if you take the weight means what? Anybody can tell me simple words? Weight means, within one word we should tell. Mr. Kaushik, weight means one word. Weight means what? Force. Force exerted by a body. That is why a weight of the object is equals to mass into acceleration due to gravity. Is it yes or no? Suppose if you take Earth acceleration due to gravity. If you take Moon acceleration due to gravity. Is it right or wrong, everybody? Yes. So we can say weight is not constant. Understanding throughout the universe. It will varies from place to place. Now, I'm saying that if any object, for example, as we know, mass is measured by beam balance. Mass is measured by beam balance and weight is measured by what, guys? Anyone? Weight is measured by? Weight is measured by spring balance. Are you clear what I'm saying? Weight, mass is measured by beam balance and weight is measured by spring balance. Okay. Now, if you take spring balance, what is the unit of weight? Anyone? What is the unit of weight?
Newton, sir.
Newtons. Okay. Now, suppose I have given you one spring balance. Basically, spring balance by extension of spring will measure the mass. So now I have tied one, now suppose some stone. Now, if I measure with the help of spring balance in atmosphere, for example, the spring is extended up to, I'm saying it is equals to 150 grams. Understanding? And force is, it will be some newtons. Understanding? Some newtons equals to that. Now, if you notice it, all of you observe, a spring balance at a time we can measure one side in grams, one side in weight. Means it is in grams means mass, another one is weight means newtons. Both we can measure with the help of spring balance. Okay. Now, if I measure the stone in atmosphere, the mass is showing 150 grams. Now, the same, atmosphere means air. Now, the same object I have taken into the water and I dipped fully or small. Have you noticed it? The metal cylinder in air, how much it is showing, Hari? What is the graph? Everybody, all of you tell me. 150 grams. Understanding? How much it is showing? 150 grams. Now, I have dipped into the water 1/3 of the cylinder. Now you notice what is the mass is showing? Everybody. Everyone. 140 grams. Understanding? Next, I dipped almost 2/3 of the cylinder. Now mass is showing how much? Everyone. Yes, please.
30 grams.
130 grams. Understanding? Are you understanding, everybody? Clear? Now, if I completely dipped, then what is the mass it is showing? All of you.
120.
Yes. 120 grams. Okay. Now, if you notice it, when I measure in air, 150 grams. When I measure in completely immersed in water, 120 grams. So what is the difference in mass? Just mass, you notice it. Mass is equals to what is the difference? 150 minus 120, which is equals to how many grams it is varying? Yes,
30
please.
grams.
30 grams it is showing the difference. Means because of what force? Anybody can tell me? What? Because of only one force. What is that force? Buoyancy force. Understanding? So when the buoyancy force is greater, when the object is fully immersed or partially immersed? Anyone?
Fully immersed.
And one body is fully immersed, then the buoyancy force exerted by the liquid is greater. Now, you will convert into weight. Suppose I want to convert 150 grams into weight. Let us see. Weight also varies because weight only varies. Mass of the object is always remains constant, but due to the buoyancy, it is showing less mass here. Now, if we take into the weight, suppose 150 grams means we want to convert, as we know, 1 kilogram is equals to how many newtons? All of you should tell me. 10 newtons. Yes or no? Now, 1 kilogram is equals to 1000 grams. 1000 grams is equals to 10 newtons. Now, 1 gram is equals to 10 divided by 1000 newtons. Yes or no, Hari? So, 100 cancel. So, which is equals to 1 by 100 newtons. Okay, which is equals to 1 gram. Now, if I'll convert 150 gram, so 150 into 1 by 100. So, how many newtons, everyone? How many newtons? 1.5 Newton. Yes or no, everybody? Yes, please. Here 1.5 newtons. Coming to here, what is the nut? 1.4 Newton. Here 1.3 Newton. Here 1.2 Newton. So what is the change in weight? Anybody? Change in weight. All of you should tell me. Change in weight is equals to what? 1.5 minus 1.2, which is equals to how much? 0.3 newtons. So this is what? Loss of weight. Loss of weight of the object when it is went from air into water. Have you noticed it, guys? Everybody? Yes, please. Arun?
Yes.
That is what. So this loss of weight is happening because of one force. What is that force? Everybody?
Buoyancy force.
Force. So if any object is immersed fully inside the liquid, then the buoyancy force is exerted more. So this is the reason when we are swimming, we will feel lighter than actually what we are. Understand, everybody? Because of this same reason. So hope everybody understand. So please, whatever you understand, please write it. Then we will continue from here. Everybody clear? Mitakshri, Abhirami, all of you. So I'm giving 2 minutes time. Please say it. Then we'll continue.